All right, now that we have a firm understanding of the product rule, we should be able to take the derivative of a couple of examples of a product of two functions. And what we have here is the same exact example we started the whole entire lesson with, where we had that question, hey, can we just take the derivative times the derivative for the product of these two functions? And we're like, nah, that doesn't work. We had to expand that thing out and then take it term by term. But now that we have the product rule, we should be able to apply it thusly. So let's see. This is what I say in my head. Let me clean up that equal sign. It looked ugly. I take the derivative of the first times the second. So the derivative of the first one will be 2x times the second one, x minus 1, plus the first one times the derivative of the second one. So the first one, just write it down. Derivative of the second one is 1. You don't have to write it down, but I'm gonna. There we go. And now to make this for sure match up to the one that we did earlier, let's go ahead and do some distribution. I'm going to distribute that 2x through the parentheses here. 2x squared minus 2x. And yeah, let's go ahead. Don't forget to distribute your 1 through the parentheses over here. So plus x squared plus 1. Combine our like terms. 3x squared minus 2x plus 1. Is that what we got before? Well, here, let me just scroll back here a little bit, and boom, 3x squared minus 2x plus 1. Product rule? It seems to work. Well, what do you know? All right, so let's look at a slightly more complicated example here. Let f of x equal x times e to the x. We want to find the first derivative and then find the nth derivative? Okay, nth derivative just means basically that I'm finding a formula, and that formula would give me any derivative number that I wanted to, the third, fourth, 100th, whatever. Okay, if you say so, Mr. Calculus. So let's first start by taking the first derivative. I mean, that makes sense. And notice that I'm going to have to use the product rule on this. Why is that? Because you have a function times another function. So the product rule is the way to go. So in my head again, I'm saying derivative of the first one, 1, times the second one, e to the x, plus the first one times the derivative of the second one. So the first one is x, and what's the derivative of e to the x? It's e to the x. There we go. All right, now I'm not quite sure where this one is going to go here. In order for me to find the nth derivative, I'm going to go ahead and maybe box this one because that's the answer here. Maybe I have to factor this one. Maybe I don't. I don't know until I do a couple more examples. I may have to do a few more examples to try to establish some sort of pattern here. So maybe I do factor this out. So if I factor out an e to the x, then I have 1 plus x. All right, and then let's find the second derivative here. So boop, boop. Okay, so I'm going to go back up over here. I could do this one if I wanted to. I'm going to go back up here to this initial one here and take its derivative. So the derivative of just e to the x there is just going to be e to the x. Plus, and now x e to the x is the derivative that we found right here, right? That's the same thing. I'm finding the derivative again, so it should be the same thing as that first derivative, which is e to the x plus x e to the x. Okay, so I'm going to write that down again. X e to the x. All right, and then combining these up, I have 2e to the x plus x e to the x. And then maybe factor out again. All right, so I have an e to the x I can factor out, and this time I have a 2 plus x. Okay, so either one of those. Let's keep going. I don't know. Do you already see a pattern? 2 things doesn't establish a pattern. Are you kidding me? All right, so here's the third derivative. And again, I'm going to go up to this version of it. What's the derivative of 2 times e to the x? It's 2 times e to the x. And then we're going to find the derivative of x e to the x. Are you ready? We already did. It's right here. It's in red. We just keep using it over and over again, so write it down again. Plus e to the x plus x e to the x. Combining like terms gives us 3 of these things. 3e to the x plus x e to the x. Do you see where this is going? Let's factor out this e to the x business, and I'd have 3 plus e to the x. All right, maybe now that's enough of a pattern. Let's see. Notice that this was the first derivative, and it has 1 plus x inside the parentheses. This was the second derivative, it has 2 plus x inside the parentheses. Third derivative, 3 plus e to the x inside the parentheses. Maybe we do one more. But what? Let's take a guess. Fourth derivative. I'm going to take some sort of guess here, go out on a limb. I write the fourth derivative like this, remember, of x. Would it be equal to e to the x times 4 4 plus, come on, plus e to the x? Would it be? Let's just check it. So this is the question mark. And we will go back up to this level and take its derivative. So let's see. The derivative of 3e to the x is indeed 3e to the x plus, and the derivative of x e to the x is the same thing that I had right up here, e to the x plus x e to the x. And when I combine my like terms, I get 4 of them. And then whenever you factor out an e to the x, you get 4 plus x. Oh, so I was wrong. This shouldn't have been an e to the x inside here. This should have been an x, silly. Man. All right, there we go. So we've established a pattern. So now let's generalize said pattern. And the derivative, the nth derivative of this function should be e to the x. Let's see if I can get it right now. This number here, 4, is the derivative number. 3 is the derivative number. So that's got to be n. Plus, is it an e to the x inside here? No, it's not. It's an x. There we go. So I have just found a formula for the nth derivative of e to the x. I think I have some pictures to go along with this one right about here. So we see the original function right here in blue, and then we have the green one. Now, notice that the green one here crosses the x-axis approximately right there, right? And then if I follow that thing down, this must be where you have a horizontal tangent line. You have a horizontal tangent line here. There is, it's hard to see, but that's a relative minimum right there. All right. What do you think? One more, or should we hold that for another video? Let's hold that for another video.